Hi everyone, this is an example getting into using area in a real world application, but it's also got some arc length in it. I really like this one. It's a pretty cool one, a little bit tricky, so you can see where you can have some pitfalls. So this is about a windshield wiper and how far different points on the wiper move. In fact, I'm just going to do one for the purposes of this example, and how much area it clears. So you've got the picture here. I did make a Desmos animation just because basically I'm totally geeking out on Desmos right now and I love it. So if you want to check it out, you can follow the link. Let's see if I have it open. I'm so excited about being able to make all these things happen. So this is what we've got going on. We've got the wiper moving, and the first part of this problem is interested in the farthest point on the end of the windshield wiper, the one that moves the farthest, and exactly how far is that moving. So back into here, we're talking about this arc right here. And we know we have the formula S equals R theta. We're told that the windshield wiper is 16 inches long. And then we're told that the arm that it is attached to is 18 inches long. And it's attached right at the midpoint of the wiper blade. So let's see, if this is 8 inches right here, then this right here has to be 10 inches. So there's a little bit of trickiness even with just figuring out what the radius of the different parts of this are. So this inside swipe has a radius of 10 inches, and that outer swipe looks like it has a radius of 26 inches. Okay, so this is going to become a 26 inches. And then we're given that it rotates through 100 degrees. So this whole thing right here is 100 degrees. But we know that if we're going to use the arc length formula, we've got to convert that. So theta is 100 degrees, but we're going to multiply by pi over 180 because we don't want those degrees in our units, right? If we multiply right now by 100 degrees, your big clue that that's not good is that your units become degree inches or inches times degrees, however you want to say that. They become nonsense. So I can cancel out my degrees, which is excellent. I can knock out a 0, and then 10 over 18, I can cancel 2 out of that and make it 5 ninths. So I get 5 ninths pi, or 5 pi over 9. And that will give me the distance that that far point is moving. 26, oh, I have no idea what that is. Ooh, so here, got my calculator. 26 times 5 over 9 times 5 pi. 26 times 5 pi over 9. Hopefully I know how to use this calculator. What is that giving me? Hold on, I don't think I believe it. 26 times 5, I don't believe it. Okay, hold on. Okay, so on my calculator, these ones are always a pain. We want 25 times 5 times pi. 25 times 5 times pi. Is that really right? Hold on. 26 times 5 times pi. Okay, so let's see if I can get this right on the scientific calculator. 26 times 5 times pi. 480 divided by 9 is about 45.4 inches. So let's make that approximate. Okay, so the outer edge of the wiper is traveling roughly 45 inches in one swipe. This next part is kind of looking ahead towards part 3 of this section, where we talk about the speed of something moving along some sort of arc. So here, if the blade makes 2 swipes per second, how fast is the tip of the blade moving? So we can figure out how far it's moving. 2 swipes is going to be 2 times our 45.4 inches, so about 90.8 inches. And it does that in 1 second, so we can just add per seconds to that and we're in great shape. Okay, the last question here is asking what area is cleared by one swipe. So back up in the picture, we're looking for this interesting segment right here, and you do have to be careful about this. So we are going to want our S equals 1/2 r squared theta formula. But we have something a little complicated going on. We have this 26-inch radius for the whole thing, but we don't want the whole thing. We need to leave out this little 10-inch radius chunk right here. That should not be included in our answer. So some people will try to do 26 inches minus 10 inches and say, okay, well, then we have this 16-inch radius, and we have our 100-degree angle, or 5 pi over 9. So if we plug those into the formula, that should give us our answer. But that's not actually true. What that really gives you is if you rotated around this point, that 16-inch radius. So it's a smaller chunk. It's not going to give us as much as we want. So that does not work. Avoid that temptation. What you're going to have to do is find the area of the entire thing and then subtract off the area of that little inner 10-inch radius section that we miss. So for the entire thing, we're going to have 1/2 of 26 squared times our theta, which is 5 pi over 9. And then we need to subtract off 1/2 of our 10-inch radius area multiplied by theta, which again is 5 pi over 9. And then an approximate value for that is great. And I got 160 pi, or approximately 502.65. And our units are inches. This is area, so this should be square inches. Okay, so hopefully that makes sense. It's a little bit trickier use of our area formula, but just recognizing that as a bigger circular sector minus a smaller circular sector should make it work out. Thanks for watching.